Hello everyone! This is just a quick video to inform you of what marble actually is. But not these marbles though. The marble that is formed as a metamorphic rock. So everyone's heard of marble, but you may not be aware of what it's actually made of. Well, marble is actually metamorphosed limestone. Limestone is a well-known sedimentary rock that is composed of a mineral called calcite. Living in WA, you may have visited a crystal cave before. These are almost entirely made of limestone. I've attached some photos that I have taken myself of these caves for those who haven't seen one before. The chemical composition of limestone is primarily composed of calcium carbonate, and as a result, marble is also primarily made up of calcium carbonate, which composes roughly 90% of the rock. The purity or the percentage of calcium carbonate in marble determines its quality and suitability for different applications. Well, now you must be wondering how marble forms. As mentioned previously, marble is actually just metamorphosed limestone. Metamorphism occurs when solid rock changes composition or texture, usually due to intense heat or pressure without the mineral crystals melting. For marble, metamorphism usually occurs as a result of two factors. The first factor being a result of convergent plate boundaries, or the second being contact metamorphism, both of which are subjected to extreme heat or pressure as required. When this metamorphism occurs at around 500 to 800 degrees Celsius or 15 to 30 kilometers deep, the pre-existing limestone undergoes a chemical and mineralogical transformation. The limestone experiences recrystallization as a result of this metamorphism, which causes the original calcite minerals to be destroyed and for new crystals of calcite to grow in its place, those of which usually grow larger and interlock together to create marble. This graph perfectly depicts the process in forming marble. Limestone has clearly undergone contact metamorphism when this intrusion has made its way through the pre-existing rock, subjecting the limestone to intense heat and pressure, which creates the marble seen beneath the limestone but above the intrusion. So this explains why marble is really just limestone that has undergone metamorphism as a result of intense heat or pressure. Okay, so marble is actually pretty interesting. But how do we actually know that marble is formed from the recrystallization of limestone? The answer to this is hydrochloric acid. When hydrochloric acid is dropped onto marble, it bubbles and fizzes and carbon dioxide is released as seen in the video on the left. This reaction can only occur when a rock is composed of the mineral calcite, which is true for both marble and limestone. Marble also reveals information about the environment of which it was formed. When marble contains larger crystals, it indicates that it was formed in an environment with higher temperatures or pressure, whereas smaller crystals indicate that it was formed in a less harsh environment. On the right, we can see the effects of hydrochloric acid on both large crystals in A and on small crystals in B. These images reinforce the idea that marble is in fact the result of recrystallization occurring in limestone, and the conditions in which limestone undergoes recrystallization will affect the size of the calcite crystals. Now we know how marble is formed and what it is made of, but what does it really look like? As mentioned previously, marble is made of calcium carbonate. While the percentage of calcium carbonate present in the marble can also determine its appearance. High quality marble typically has a high percentage of calcium carbonate, which results in a dense, more homogeneous rock with fewer impurities, such as the pure white marble you see more frequently. However, marble with a lower percentage of calcium carbonate will have more impurities and may contain small amounts of other minerals such as clay, silt, and iron oxides. The presence of these minerals in marble is dependent on the geological history and the environment in which the marble is formed. If minerals are present, the chemical composition of these minerals is what gives marble its varying colors. However, when marble experiences tectonic movement, these colorful minerals can become stratified in the direction of the pressure, therefore creating the unique patterns that you sometimes see within pieces of marble. But I should mention that some metamorphic rocks, such as quartzite and marble, will not necessarily exhibit foliation because their minerals, which are quartz and calcite respectively, do not tend to show alignment because the pressure experienced by the marble and quartzite is usually more uniform. Marble and quartzite undergo similar processes of formation, and they quite often get mistaken for each other as they look alike. So here I've included images of both unpolished and polished marble and quartzite to highlight how similar yet different they can look. Unfortunately, that is the end of my marble presentation, but now you can brag to your friends that you know what marble actually is. I hope that you learned something interesting about marble today and that you now know how to identify it if you were to see it out in the field. Thank you for listening. Bye.